Here in the 12th one, a teacher demonstrated the principle of conservation of the linear momentum using two gliders A and B and an air track. A has the same mass as B. A and B were initially stationary. Then A was pushed gently towards B as shown. Here the first question they're asking, state the principle of conservation of linear momentum, right? And here they have given 2 marks, right? I will explain why they have given 2 marks for this question. The first thing you have to mention that total momentum remains constant, or you can tell it like total momentum remains constant, or you can momentum before a collision, total momentum before a collision, for the collision is equal to total momentum after the collision, right? If you write this point, you will get only 1 mark. You have to explain one more thing. What? When there is no external forces, right? When there is no external, or you can write it resultant over here, resultant, either resultant or external, you will get the mark. No external force acts on the system, right? So if you have like this one, you will get the other mark, right? Always keep this in your mind. What, when they ask you to state the principle of conservation of linear momentum, you had to write these 2 points. What, the first one is total momentum before a collision is equal to total momentum after collision when there is no external or resultant force, or you can mention if the system is a closed one, right? In the part B, a magnet was attached to each glider, right? The glider collided and stuck together. A data logger sensor was used to record the velocity of A. The velocity recorded after the collision was half the velocity recorded before the collision. Deduce whether these results show that the law of conservation of linear momentum is obeyed, right? Here this is our system before the collision, and here is glider A, right? And here is glider B, and suppose this one has mass m, this one has mass m, and if this one is moving with a velocity of 2v, right, momentum before the collision of the system is, right, 2 times mv. Why? This one is stationary, so it has no momentum, right? So after the collision, when they stuck together, right, they have mentioned what the velocity is now halved, so it is just v, but the mass is doubled, so the momentum is 2 times mv, so momentum remains constant, right? And there is no external forces, right? Then you have to mention this one in 2 points. How? First one, you have to mention that momentum is mass times velocity, and after the collision the mass is doubled. Right? Then even if mass is doubled, our velocity is now halved, right? So momentum remains the same, so you have to mention that one, right? But velocity is half its original value. original value. Therefore momentum remains the same. Remains the same. So the law is obeyed. Right, keep in your mind what when they have mentioned you, there are 2 marks, so you have write 2 points. So 1 mark for this one and the other mark for this one. Right, the next one, explain why the force of attraction between the two magnets did not affect this demonstration. Right, here's our glider A and here's our glider B. Right, here they have mentioned force of attraction, so we will have force over here, and you should know one, these two forces are Newton's third law forces, so they have the equal uh, magnitude and opposite direction. So what will happen, due to this force our mass or the glider A will accelerate towards this direction, and due to this force, I mean this one, due to this force our glider B will accelerate towards this direction. So they will have equal and opposite accelerations, so they will cancel out, right? Or we can conclude we don't have any resultant forces acting on the system. Why? These two forces are equal and opposite, right? Even here they have mentioned it is 2 points, so we had to explain our answer in 2 points. Right, can mention that the gliders accelerate in opposite directions, opposite directions, right? uh, why? The magnetic forces are equal in size and opposite in direction. Forces are equal in size and opposite in direction. Right, uh, then you can mention, so the resultant force on the system is 0. So the resultant force on the system is 0. Right,